both the green in half. And then we'll create our tabs here in a second. Some of you have some scissors at your desk, and you can cut on the dotted line to create your tabs. Okay. Thank you. Happy Valentine's. Okay, so most of this is review, but we're just going to talk about like the formula and how to apply it graphically, or just apply it and evaluate the formula. Alright, so the segment bisector tab, that part is review. It does give you a definition to explain what a bisector is. It could be a point, array, a line segment, or plane, basically that intersects the segment at the midpoint. So if I'm dealing with, I'm just going to underline this, segment bisector. The important thing is that it intersects the segment at the midpoint. So we're going to just add some labeling on the example so we can understand what occurs. First, we need to add a point where the line intersects the segment, and we're going to name this segment A, B. Our point of intersection would be our M for midpoint. The key to this is one, for it to be a bisector, I'm going to put a little star up here, must see tick marks. Okay, for that to work. And because we see those tick marks, and because a bisector intersects the segment at its midpoint, then I know that AM, this segment here, is congruent to MB. The two parts will be equal to each other when dealing with the bisector. All right, so for example 1 here, they want us to find the x, okay? Which parts are congruent here?
AB and BC.
AB is going to be equal to BC. So to set this up, we should start by writing x plus 9 equals 4x. We need to solve for x.
Minus x on both sides.
Yep, minus the x on both sides to eliminate the smaller x on the left side, leaving us 9 equals 3x.
And divide.
Then divide by 3. And so that means our x equals what?
3.
X equals 3. We're done. Okay? All right. So we did example 1. I want you to try and do example 2. And solve for x. Use our same steps for your setup. Okay, so you should have had 5.5 for example 2.
Yes.
You should have started off by adding 2x to both sides. That's the smallest variable. So that would have left you with 6x minus 12 equals 2. Or equals 21, sorry. Which would have been 6x equals 33. And it should be 33 divided by 6, which is 5.5. All right, so midpoint. The key thing for a midpoint is that it divides into 2 congruent segments. When you have points on the coordinate plane, we have the midpoint formula. This is when we have points in a coordinate plane. This formula right here, I'm going to box it, is basically, sorry, go back. Is basically the average of each coordinate. I'm not going to ask you to memorize the formula because it is on the formula chart, but we just need to apply it. In order to do that, you first need the actual coordinates of your point. So we're doing the midpoint of AB, so we need the coordinates of A off on the plane.
That'd be 5, 1.
No, not for A. 5 is over here.
Oh, wait, -5.
It is -4, comma 1. To the left 4, up 1 gets me that point A. All right, we need also the coordinates for B.
5.
That is not 5.
4.
Okay, can I do coordinates of B? Can you find it off the coordinate plane? It is 2, comma 4. To do the formula, to find the midpoint M, you have to add up your x coordinates. These are your x coordinates in the first, so that means -4 plus 2 divided by 2. And you add up the y coordinates. That is 1 plus 4 divided by 2. When I simplify this, a -4 plus 2 is going to leave me with a -2 over 2. And 1 plus 4 is going to give me 5 over 2. Sorry. These are reduced to my final answer, which is a -1, comma 2.5. Half of 5 is 2.5. So this is my answer, the coordinates to the point of the midpoint. So I want you to try example 4. You have to find your coordinates for C and D first, and then apply the coordinates to the formula. It does come out to be a whole number answer. So if you get a decimal, check your math. Check your integer rule. So try that one, please. Okay, guys, you should end up with 3, comma -2 if you did it correctly. We need clarification on that example. All right, the last thing is, oops, sorry, what happened? Is the distance formula. The last tab. So the distance formula, we're going to show you 2 ways. It's kind of what we talked about in the activity on Friday. You can use the formula here, which is d equals the square root of the difference of the x coordinate squared plus the y coordinate squared. So you have to subtract to do difference. So x2 minus x1 parentheses squared and y2 minus y1 parentheses squared. Again, so on example 5, since we are trying to find the distance from A to B right here, I know that's not a very accurate line, but let me fix that. Okay. I can use the formula with the coordinates. My A is at a -3, so -3, comma 5. And my B is at 2, 3, 2, comma 3. So if I use it with the formula, I'm using my x1 for my A as the first x coordinate and x2, y2 for the B. So what we do is just plug everything inside the formula, which means in the first parentheses, I'm doing the difference of the x values. That would be 2 minus the -3, parentheses squared, plus the difference of the y values. That would be 3 minus 5, parentheses squared. You have to do the operation inside the parentheses first. So when I simplify this underneath the radical, this comes out to be 5 inside the parentheses and square it, plus for the next grouping, this becomes a -2 inside the parentheses and square it. Because we're going to end up squaring the number, every time you square a number, I don't care if it's an integer or a decimal, okay? If it's going to always turn out to be a positive answer. So I know we have a -2 here, but when you square it, that is a +4. 25 squared, or 5 squared, is 25. These two numbers are underneath the radical. You do the adding last, and then simplify it. So this becomes really just root 29. This is not a perfect square, but there is no perfect square that goes into 29. So this is the exact answer. And if I wasn't sure, I would have to go to my calculator. Oops, right here. Go here and do second x squared 29. I get a decimal answer, so that tells me it's not perfect. If I wanted the approximate answer here, you would set approximately to the nearest tenth, 5.4. You round one decimal place. So you could say this is approximately 5.4. All right, so I want you to do example 6. I'm going to come by and stamp this, that it's been completed. You have the right answers, and it's going to go into our spiral. I'll put the table of contents up here in a second. And then I'm going to give you the guided practice to do next here. We will do probably the odds. You would do the evens to check your understanding. So finish the last example, and then I'll pass out. All right, guys, add this to your green notes, guys, real quick. I'm going to show you a shortcut. You can use it on the guided practice. If you want to use your segment right here that you're trying to find the distance with, and if you want to, I'll wait. If you're struggling with your integer rules or figuring out what number to subtract or what it comes out to be, you can create a right triangle. So the other option you can use instead of this formula, or make right triangle and use Pythagorean theorem. So if I make a right triangle with this segment, I would have to go up and then over, like such. So you have to physically draw the right triangle. When I do that, I can count this leg. This leg is 1, 2, 3 units. And then I can count this leg over here. This leg is 8 units long, which is the same numbers I end up with Pythagorean theorem. Since I have a 3 and an 8, this would be 3 squared plus 8 squared equals c squared. Well, this becomes 9 plus 64 equals c squared, which is when I get 73 equals c squared. And then the last thing you do is take the square root. So c, which is your hypotenuse, is root 73. So if you rather make right triangles and do Pythagorean theorem, you can. It's the same thing. So on the guided practice, guys, first set here, they want us to do the distance formula right here. That's when I'm using the formula d is equal to the square root of x2 minus x1 parentheses squared plus y2 minus y1 parentheses squared. So if I don't have a graph, then I need to pull the points, my x1 and my y1, my x2 and my y2, from the coordinates. I have to put the values from the coordinates. So I'm going to talk about the odds. You're going to do the evens. I'll come by and check for right or wrong answers when I stamp. So if I'm plugging in here, keep everything underneath the radical and put in your numbers that you're going to substitute from the coordinates inside the parentheses. So what would go in the first parentheses? Negative 1 minus 7. It's not plus, it's minus. What goes? It's plus when you're doing midpoint. You add when you midpoint, and subtraction with distance. All right, what about for your y2, y1? What's going to go in the second parentheses? 5 minus 11. And then it's parentheses squared. So a negative 1 minus 7, what does that get simplified to? What number is going to remain in the parentheses? a -8, and then we square that number. 5 minus 11.
6.
So that's 6 that's inside the parentheses, and then we square that number. So now we're squaring the -8. What does that turn into?
64.
Yep, it's always a positive answer. So 64 here plus, what is 6 squared?
36.
So now I'm doing 64 plus 36. What does that become?
100.
So the square root of 100 equals what?
10.
It's a perfect square, so that's our final answer, 10. Now, if I give you the graph and you want to find the distance, and you can either use your formula that you did on number 1, or you can draw and create. I don't know if you're seeing how I'm making these right triangles. Draw vertical and horizontal legs. You can do it that way. I'm just going to show you, or I can go like this. Either way, it has to make a perfect right triangle. So it doesn't matter what direction you go, just draw it. What is our vertical leg? How long is it?
Oh, it's 6.
So I put 6 outside here. How long is the horizontal leg? So I could, if I want to do Pythagorean theorem, and just say 6 squared plus 5 squared, that's going to be my c squared. Do we have questions how I got the 6 and the 5? All right, what is 6 squared?
36.
So 36 plus 5 squared,
25.
that's going to equal my c squared. When I add these together, this comes up 61 equals c squared. But to get the c, you have to take the square root. Okay, I'm just going to come over here to the side. So c equals the square root of 61. Not a perfect square, and no perfect square goes in there. 61 is prime. Okay, so I could say approximately, using the calculator and going second x squared 61 and get 7.8. Okay. Either one is acceptable. If you keep the exact answer, just make sure you simplify it. All right, so the first section is distance formula. The second section here is midpoint. So the midpoint formula, M, capital M, is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So we're using a different formula for this section. We're still doing x and y's. So when I simplify this, my x coordinates here would be 9 plus 17. Then I divide it by 2. And my y coordinates would be 5 plus 4. And divide by 2. Do the addition first. So this gets simplified to the order pair 26 over 2 and 9 over 2. Oops, sorry. Reduce or do the division. So the answer is 13, comma 4.5. Now, last one, guys, you do need to watch this because this is going to require you to work backwards. We're looking at a pattern. We're looking for a pattern. Okay, the way this works, because the point M is the midpoint and that has been given to you, and they want you to find the missing endpoint, okay? You need to line them up like it was a segment. We're talking about segment right here, AC. So it goes from A to the endpoint C. M is your midpoint. I forgot to put the A there. Sorry. M is the midpoint. So what we do is we take the given information, which is they tell us M is at 0, 8. They tell us C, it is at -3, 6. And you have to look at how the numbers change. If I'm looking at the X coordinate, because we're trying to find the coordinate that belongs over here, okay?
Would it be positive 3, -6?
Not +3, -6, no. Your +3 is right. It went from 0 to -3. So how did it change?
Like gain 3.
It gained 3. Okay, so we're doing that same 3 in this direction. So that makes that, what would that make that number? No.
310.
Oh. What's the difference between 0 to with the unit? If we're starting at 0 and I go 3 in the other direction.
No,
We're already at a -3. So it's a +3. Yes. Yeah, so this one's +3.
So if you lost 2 going to a negative, wouldn't you gain 2 going to a positive? This one?
So yeah, you're longs 2, right? Right? You lost 2?
Yeah. And
Okay.
left
I agree. I'm agreeing. You gained 2. I'm agreeing with you. You gained 2.
10.
Because 8 to 6 is -2. This way I'm losing 2. So I gotta do the opposite, going in the other direction. So this would be 10.
Can I read the back?
You have to look at the pattern between the numbers. How are they changing? And do the reverse of that pattern, going in the other direction. Yes.
Can I read the back?
Yeah. It's like, even if I did the math, if I was at 3 and I subtract 3, that would give me 0, right? And if I 0 and I subtract 3 again, that would give me -3. Do y'all see the pattern between the numbers? So like if I was 10 and I subtract 2, that would give me 8. If I subtract 2 again, that gave me 6. It has to be the same distance for it to be a midpoint. All right, you're going to finish this. I'm going to stamp it. This needs to go in your spiral after the green.